This is section 2.2. We're going to evaluate and graph polynomial functions. First of all, when we are talking about polynomials, each polynomial will have a degree and a leading coefficient. And the degree is the highest exponent that is in the polynomial. So if you look at this example down below, we have f of x equals 3x to the fourth plus 4x squared minus 7x minus 9. The highest degree is our highest exponent is our degree. So the highest exponent you see here is 4. And so the degree of this polynomial would be 4. Now polynomials also have a leading coefficient. And the leading coefficient is the number that starts out or leads the polynomial. But you have to be careful with this because it has to be in order. So make sure that you have the highest exponent listed first, and then it goes to the lowest. So here we have 2, 1, and then none. So the highest exponent is 4, and the number before this, which is 3, would be our leading coefficient. Here are a few practice problems we're going to look at. In number 1, we're going to list the degree. And as you see, we have 3x squared plus 4x to the 6 plus 2. And the degree is the highest exponent, which is this. So 6 is the degree. And our leading coefficient, we have to be careful because this polynomial, like it is not in order. So we write this in order with the highest exponent going first and then making its way down to the least. This would be the order. And now you can see that the leading coefficient is 4. In number 2, everything looks like it's in order. The exponent on this is a 1, even though it's not shown. So the highest exponent in this one is a 1. And the leading coefficient, because this is in order, is a 5. In number 3, we do have the highest exponent right here. And so the degree is 5. And the leading coefficient is the 8 because we have the highest exponent and it goes down until it gets to the smallest. So 8 is the leading coefficient. Now what I want you to do is you should probably pause the video when you're watching this and copy down this chart. This is going to help you figure out the degrees and what type of graph it is if you were asked. And quickly, before you pause the video, I'm going to go through the degrees with you. As you can see in f of x equals 4, there is no variable here to have an exponent. So if that happens, there is no degree, so the degree would be 0. In the next one, f of x equals 2x plus 3, which is a line. We call those linear graphs. The exponent over here would be a 1. That is the highest, so the degree would be a 1. In the next one, quadratic, which we've been dealing with mostly in this chapter and in the first chapter, we have the highest exponent being a 2, so the degree would be a 2. And remember, those are U-shaped graphs. In the next one, we have a highest exponent of being a 3. These are cubic, so the degree is 3. And for quartic, we have 4 as the highest exponent, so the degree would be 4. All right, this is a practice problem that will come directly out of your book. It says, decide whether the function is a polynomial function. If it is, write the function in standard form and state the degree, type, and the leading coefficient. So we look at the first one here. We have f of x equals 12 minus 5x. And this looks very similar to the linear because we have negative 5x plus 12, which is in the form of mx plus b. So this is a polynomial function. We're going to write yes. And then it says we need to write it in standard form. This is not in standard form. We need to switch it around. Mx plus b. So we would write negative 5, sorry, not m. It would be x there. And then we have plus 12. Okay, so now it's in the standard form. We need to state the degree, which is just the highest exponent that is here, which is a 1. And the type of graph this is linear. If you look at that chart you just wrote down, you can compare. And lastly, the leading coefficient, once you have it in order, is negative 5. All right, number 2, we have f of x equals x plus pi. Now, even though the symbol pi is there, remember that pi is a very long decimal number. And so the reason mathematicians put this symbol there is because it makes it easier for us to write in an equation. So we still have mx plus b. Even though our b is in a different symbol, it's still a very long number. So this is a polynomial function. And again, this is incorrect form, so we're just going to rewrite it. And the highest exponent in this is still a 1, so the degree is 1. And if you look at the chart, when we have a degree of 1, it is a linear graph. And the leading coefficient for this one is the number right before the x, which isn't shown, but when that happens, it is a 1. All right, number 3, the last one here. We have f of x equals x minus 3x to the negative 2 exponent minus 2x to the third. Whenever you have a negative exponent, this will not be a function. So you don't have to go through and write all these answers out. You just write not a function, and you're done with the problem. Okay, now we're going to go ahead and graph some polynomials. These are going to be real quick because I've already shown you in your calculator how to do these. One thing I want you to do when you're doing your homework is I want you to give me a list of the x and y values just for practice. So we're going to go to the y equals, and we're going to write negative x with a little caret sign and a 3. And you're going to push second graph to get your table. And we're going to fill in these values. So I have negative 2 and 8, negative 1 and 1, 0, 0, 1 and negative 1, and then I need to scroll down, 2 and negative 8. Okay, now we're going to go ahead and graph this. And you can pretty much graph this exactly instead of sketching, because we have the list over here to go by. So negative 2, 8, so 1, 2, 3, 4, 5, 6, 7, 8. I'm just going to keep going up. And then we have negative 1, 1, 0, 0, 1, negative 1, and then 2, negative 8. 5, 6, 7, 8. And we're going to connect the lines with arrows. And this looks like the cubic graph that I showed you in that chart. All right, one more practice problem with graphing. Again, you're going to go to your y equals. And you can always check the graph by hitting graph to make sure you graphed it right. I'm going to clear out that old one, and I'm going to put the new one in. So x to the fourth plus 6x squared minus 5. And I'm going to get my values from my x and y chart by hitting the second graph. And I have negative 2, 35, negative 1, 2, 0, negative 5, 1, 2, and if I scroll down to 2, I get 35. And we can go ahead and graph this. This time, I'm only going to graph negative 1, 0, and 1 and kind of estimate the 2 and 35. That's just too big of a number to plot. So let me make my graph over here. So we have negative 1, 2, 0, negative 5, and 1, 2. Okay, so, and then if we were to sketch the other one, it would be really far up here. So we'll just kind of looks like a U, and maybe mine's completely off, but if you go to your graph, it is actually a U. So this should look more like a U instead of what I got going on there. And then you're done. All right, now when we do these graphs, we're going to be talking about the end behaviors. And what I want you to do right now is pause the video and go to page 97 in your book and copy down the blue chart. Okay, when we talk about end behavior, if we have several different graphs here, I'm just going to draw you. You don't need to copy this down. I'm just explaining what that chart is telling you. Okay, so if we look at the end behavior is talking about what are the ends of the graph doing. And so the symbol they use for end behavior, or for the function, instead of writing the word function out every time, they just write f of x. So if we look at this function, it's on this side, and we know all the x values over here are negative. So as the function goes to negative infinity, because we're talking about all these numbers over here, what does the graph do? We're going to say that the function goes to positive, because all these values are going up. Positive infinity. And I should have wrote over here, and I'm sorry, should have wrote x. So as x goes to negative infinity, our function goes to positive infinity. So as all these x values are going to the negative direction, our function is going in the positive direction. And this is how you would write it. And now remember, there's two ends to the graph. So this is the first end, here's the second. So we also have to talk about this one. So if we go to this side, which is all of our positive values, so we'll just write x. X goes to the positive infinity, or positive side. Our function, what does our function do? It goes up. So it also goes to positive infinity. Okay, so there's the first one. And now in the second one, remember there's two ends, so here's the first one. So you're going to rewrite the same exact thing. Okay, and I'm just going to write it up here. X goes to the negative side. Our function, this time it goes down. So that goes to negative infinity. And now the other side over here, there's two ends to the graph. As that x values go to positive infinity, the function goes to positive infinity. So this is end behavior. And then the last one that I'm going to show you, there's two ends. So this time we're still going in the negative direction, so x is going into the negative direction. Our function is going into the positive direction. And over on this side, all these x values, which are positive, our function goes down to negative. So there's your end behavior. So here are some examples that they give you the function, and they said describe the end behavior of the function. Now that chart that you got in your book gives you something at the top that says if your degree is odd and your leading coefficient is positive, this is what your end behavior is going to be. So instead of going through our calculator and graphing all of this and then going through ourselves and figuring it out, they give you shortcuts. So let's look at our degree. Here's our degree. Is that an even or odd number? Well, 3 is an odd number. And then our leading coefficient is a negative. So if you look at the chart that you copied down and you go to odd negative, which is the second one on the top, it gives you the end behavior. So just copy that down. So, and they have it backwards, which it doesn't matter how you write it. I'll just write it how they put it in the book. So our function's going to go to positive infinity on the negative side. And our function will go to negative infinity on the positive side. And they even give you the graph. All right, number 2 down here, we have the degree over here. Well, that's going to be a even number. And our leading coefficient, remember, 2, that's not our leading coefficient. It has to be in order. So if we put this in order, -3 is actually our leading coefficient, and that is a negative number. So you go to the chart and you look for even negative, which I see is at the very bottom, second one down. And it looks like it says, as our function goes down, that's going to be on the negative side. Whoa. Let me just rewrite that. And this is just coming directly from the book. So this shouldn't be too hard for you. Okay, so those answers came directly from the book and you're done without having to do it yourself. Okay, next we're talking about direct substitution to evaluate this function when x equals -2. And direct substitution is just saying put -2 directly into this equation and figure out what the answer is. And we've all done this in algebra, pre-algebra. So I'm going to put -2 every single place that I see an x. And it's always good to put parentheses. And now we need to evaluate this. So -2 squared is a +4. 2 times -2 is -4. And then we have +9. Okay, so we have 4 plus a -4, that cancels out to 0, plus 9 is 9. So there's the answer. All right, now another thing your book will ask you is to use synthetic substitution. I'm going to show you this, But I'm going to let you use the direct substitution whenever they ask you to do the synthetic, simply because direct is a much simpler way to do this. And if you ever take an ACT or MME, they're not going to look and see if you actually use synthetic substitution. They just want the correct answer. So synthetic substitution is, we're going to put this -2 out here that they want us to evaluate. And we're going to draw a box. And we're going to first write on the top row here all of these coefficients that are out here. So we have a 1, a 2, and a 9. And the first thing you're going to do is drop down the 1. And we're going to multiply this 1 by the -2. So 1 times -2 is -2. And then you're going to add these up. So 2 plus -2 is 0. And then multiply again. So 0 times -2 is 0. And then add again. 9 plus 0 is 9. And whatever answer you end up with at the very last spot is your answer. Which, yes, that's the answer we got in the previous slide. So I'm going to leave it up to you, whichever method you think is easier. Go ahead and do that for your homework, regardless of what the directions ask you for.